Hello my dear students of class 5, welcome to maths class once again. So in my previous online class I have taught you about the methods of SCF. So today we are going to do few questions of this exercise. Okay, so let us start with question number 1. What is question number 1? What are the prime factors of the following numbers? Here few numbers are given. We have to find the prime factors. Prime factor means we will do, okay, now what is say, we will find the prime factors by the use of the prime numbers. Okay, and you already know what are prime numbers that are divisible by its own table or by 1. Okay, so let us start how to do. Now see here how to do. Okay, what you will do is that you will write here 1225. Okay, written. Now you have to find the prime factors. That means you have to use the prime numbers. So prime numbers start from 2. 2 is the prime number, 3 is the prime number, 5 is the prime number, 7 is the prime number, okay, 11 is the prime number, and so on. Okay, these are the numbers that comes in its own table and one table. Okay, so now let us start. Okay, we are going to divide this. Okay, so let us start with the 2. So how to know that whether this number is divisible by 2 or not? What we have to do is that we have to see the last digit, and last digit should be what? Even number. So you can see here what is there? 5, that is odd number, so it is not divisible by 2. So what we have to do is that we will go for the next, that is 3. So how to know for the 3? What you have to do? We have to add all the digits. Okay, so let us add 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 5 is how much? 10. Okay, what came? 10, and 10 is not divisible by 3. No, 10 doesn't come in 3 table. That means this number is not divisible by 3. Now let us see with this prime number 5 whether this 1225 comes in 5 table or not. So it's very easy, the divisibility rule which I have already taught you, okay, for all the digits. So for 5, what you have to see is that last digit is 5 or 0. So here you can see the last digit is what? 5. That means this is divisible by 5. Okay, so let us start and do with the 5. Okay, so 5 is the prime number. So 5, this is 12. So what we can write is 5 to the 10. 12, 2 I'll give carry. Okay, so it will become 22. So 22 doesn't come. So 5 for the 20. So 2 carry. Now it will become what? 25. Okay, just keep in your mind. Okay, don't write here. So 5 5s are 25. So done. It got divided by 5. No. So now let us see again whether this is divisible by 5 or not. Yes, because the last digit is what? 5. So let us again do. So 5. See, it is 24. So 24 doesn't come. So less what comes? 20. So 5 fours are 20. So it was 24. 4 given borrowing to this, it becomes 45. So 5, how much are 45? 5 nines are 45. Now it is very easy, no? You know that 49 comes in which table? In 7 table. Okay. So 7 is also the prime number. 7, 7 ja 49, 7 1 ja 7. So we have done. So right here, prime factors. Okay, you have to do till you don't get this one, that is they are divisible by its own table. So what is the prime factor? Is 5 into 5 into 7 into 7. When you will multiply this, you will get 1225 only. When you will multiply these prime numbers, you will get this only. Okay, so this means prime factors. You have to use the prime numbers. You have to check from 2, then again not, then 3, then 5. One by one you have to check. Okay, you don't need to do with 4, 6 and all directly. Otherwise it will be wrong. Okay, so now let us see what is question number 2. Question number 2, find the SCF of the following. So here we are going to find the SCF. Here you see methods are not written. In question number 3 you can see method is written. In question number 4 also method is written. Then that time we will do by the method. Here method is not written. That means you can do SCF by any method, whichever you feel easy. Okay. So in this I am going to do long division method because that is more easy to do. Okay. So let us do that long division method. Okay. We will find SCF by long division method. Your wish. If you want by doing common division, you do by that. Prime factorization, you do that. By common factor you want, you can do that. Okay, your wish, because method is not written here. Okay, so let us do. I will do by long division method. Okay. Okay, so now let us do find the SCF of following. I said you can use any method. Okay, so here I am using the long division method. So in long division method, what we need is the dividend and the divisor. So here which one is the greatest one is 144. So this one is our dividend. Okay, and this one is our what, divisor. So let us start. So dividend will be inside and divisor will be outside. Okay, so now let's do, this is 108, this is 144. So in 108 table 144 will not come because 108 ja 108, 102 ja what, 116. You can do by multiplying. Okay, it is very easy. Okay, don't take tension or don't get confused. It's very easy. You can multiply by 2 3, you will get the table. So you can see this one is greater than this. Okay, and it doesn't come also. So less than this is what in 108 table is 108 only. So 108 1 ja 108. Now let us subtract. So from 4 we cannot subtract 8. So this 4 will take one borrowing. So this 4 will become 3. 4 will become 14. 14 minus 8 is how much? Is 6. 3 minus 0 is what? 3. And 1 minus 1 is what? 0. So we'll put the cross. Now you see we got the remainder, no? But we don't want remainder. Okay, remainder should be what? 0. So how to do is that you make here like this. Now this remainder has become your divisor. Okay, now where is the dividend? If this is my divisor, so where is my, if this is my divisor, then where is my dividend? Okay, so the dividend is this one. Okay, your dividend is this one, that is 108. Okay, so 36 how much? 108. So 36 how much? 108. If you will multiply 36 into 2 into 3 into 4, you will get. If it is there, you will get. If it is not there, what we will do? We will take the less one. Okay. So before doing, you can write the table at least till 5. Okay. So that it become easy for you to do. So 36 how much? 108. So 36 3 ja 108. So 8 minus 8 is what? 0. Put cross. 0 minus 0 is what? Put cross. 1 minus 1 is what? 0. We have to subtract it. So you can see that here we got the remainder 0. Okay. So now we have done this division. So what is the SCF? So our SCF is what? The last divisor by which it get divided. So this one is our SCF. Okay. So we can write here is that SCF of 108 and 144 is 36. Okay, so this is the SCF. I said here method is not written, so you can use any method. If it is difficult for you, you can use any other method. Okay, so here I am going to do this by prime factorization method. If you feel easy, you can do by this method also. Okay, so in prime factorization method, how to do is that in this way, we have to divide by the prime numbers. So here you can see 0 is there, that means 0 is a what? Even number, so it will get divided by 2. So let us start with 2 only. So 2, how much is 17? In 2 table 17 doesn't come. So less than this what comes is 16. So 2 8 ja 16. Okay, 17 was there, 1 carry. So 2 5 ja 10. Okay, now you can see that we got 5 as the last digit. So 5 is an odd number, so it will not get divided by 2. So let us go for the 3. Okay, 3 is also the prime number. So for 3, what do you have to do? We have to add the numbers. So 8 plus 5 is how much? 13. And 13 doesn't come in 3 table. That means it's not divisible by 3 also. Now go for 5. Okay, so it will get divisible by 5 because the last digit is what? 5. Okay, so 5 1 ja 5. Here 8 is there. So we can give the borrowing to this 5. So 5 1 ja 5. So 3 will get borrowing. It will become 35. So 5, how much is 35? 5 7 ja 35. Now see, we got 17 at last. 17 is what? It is a prime number. Okay, so it is divisible by its own table only. So directly we can do is that 17 1 ja 17. Now 204. Okay, so 4 is an even number, so it will get divisible by 2. So 2 1 ja 2, 0, 2 2 ja 4. 2 5 ja 10, 2 1 ja 2. Okay, now here what is there? Odd number at last. That means it is not divisible by 2. So let us see for 3. For 3, what you have to do? You have to add. So 5 plus 1 is how much? Is 6. Okay, so 6 is divisible by 3, no? That means it is also divisible by 3. So it will come in 3 table. 3 1 ja 3, 5 is there. So 3, we have written 3 1 ja 3. So 2 will be given to this. It will become 21. So 3 7 ja 21. Okay, now you see that we got 17 and 17 is a prime number, so it is divisible by its own table. So 17 1 ja 17. Now how to write is that we will write here prime factors. So what are the prime factors of 170? So what are the prime factors? 2 into 5 into 17. Okay, now what is the prime factor of 204? Okay, 204. So what are they? 2 into 2 into 3 into 17. Now what you have to do is that you have to find the common. So what is common? Okay, now what is common? Here multiply will be there. Okay, I forgot to put it. So what is common? 17 and 17 is common. Okay, so what you have to do is now we have to product. We have to find the product. So what is the product? What do you do? From this 2 common we'll write 1 2, and from this 270 you write 1. Okay, so 217 ja how much? So 217 ja how much is 34, and our SCF is what? 34. So you can do by this method also. Okay, you can do by long division method if you feel easy, or you can do by prime factorization method if you felt easy. Okay, now let us do what is question number 3. Now question number 3, find the SCF of the following by common division method. So here we are going to find the SCF by common division method. Both the numbers should come in the same table. Okay, that is the common division method. So let us start. So see here, what is the number? 5184, 6561. So how you have to write is 5184, 6561. So both should come in the same table. Then only we can divide this, okay, by the particular number. So you can see that here 4 is the even number, so it will get divisible by 2. But here you can see that 1 is the odd number in the last digit and it cannot be divisible by 2. So that means we cannot use 2 here. Okay, we cannot use 2 because both the numbers are not divisible by 2. Only this is divisible, this is not divisible. Now let us go for 3, whether this is divisible by 3 or not, both the numbers. So for 3 what you have to do is that we have to add. Okay, let us do here. You have to add this digit 5 plus 1 plus 8 plus 4. So 5 plus 1 is how much? Is 6. Okay, 6 plus 8 is how much? Is 14. Okay, and 14 plus 4 is how much? Is 18. So 18 is divisible by 3. That means this number is divisible by 3. Okay, now let us check for this. So 6 plus 5 plus 6 plus 1. So 6 plus 5 is how much? Is 11. 11 plus 6 is how much? 17. 17 plus 1 is how much? Is 18. We got. That means both the number is divisible by 3. So let us do it by 3. Okay. So 3 1 is 3. 5 is here. 2 given to this. So it becomes 21. 3 7 is 21. 8 now. So 3 2 is 6. Okay. So 2 carry 3. How much is 24? 3 8 is 24. So see, it got divisible. Now this one. Okay. So 3 2 is 6. 3 1 is 3. 5 is there. 2 given carry. Okay. So 3, how much is 26? 26 doesn't come in 3 tables. So 24 will go for. So 3 8 is 24. 2 given to this, it becomes 21. So 3 7 is 21. Okay. Now it will again not go with the table of 2. So let us check for 3 again. Okay. So what you have to do is that 1 plus 7 plus 2 plus 8. So 1 plus 7 is how much? Is 8. 8 plus 2 is how much? 10. 10 plus 8 is how much? 18. So this number is divisible by 3. Now for this 2 plus 1 plus 8 plus 7. So 2 plus 1 is 3. 3 plus 8 is how much? Is 11. 11 plus 7 is how much? Is 18. So both the number again divisible by 3. 3 table 17 doesn't come. Less what comes? 15. So 3 5 is 15. 2 given to 8. So 3 7 is 21 because 22 is there. So again given 1 to 8, it becomes 18. So 3 6 is 18. You have to keep in your mind, okay, that borrowing one. 3 table 21 comes. Okay, so what we will write? 3 7 is 21. Okay, here you don't get mistaken. Okay, so see carefully how I am doing. See here, I have taken a 2 digit, that is 3 7 is 21. Okay, so now what we will do is that, so we have written 3 7 is 21. Now 8 is there, that means 3 2 is 6. Okay, 8 is there, so 2 given to this, it becomes 27. So 3, how much is 27? 3 9 is 27. Again got divisible by 3. Now let us again check whether it is divisible by 3 or not. So what you have to do is that add. Okay, so 5 plus 7 plus 6. So how much it is? 5 plus 7 is 12. 12 plus 6 is how much? Is again 18. Okay, that means this will be divisible by 3. Again let us add this. So 7 plus 2 plus 9. So 7 plus 2 is how much? Is 9. 9 plus 9 is how much? Is 18. So again both the numbers are divisible by 3. Okay, so how to do is that again by 3. So 3 1 is 3. 5 is there given to 7, it becomes 27. Okay, so 3 9 are 27, 3 2 are 6, 3 2 are 6. Okay, 1 given to it, 3 4 are 12. Okay, and 3 3 are 9. Let us check again by 3. So 1 plus 9 is 10, 10 plus 2 is how much? 12. So yes, by 3. Okay, so 2 plus 4 is how much? Is 6, 6 plus 3 is how much? 9. So again by 3. So 3 6 are 18, 1 carry, it becomes 12. So 3 4 are 12. Okay, 3 8 are 24, 3 1 are 3. Okay, now let us check. Now let us check again. So now see, we will add this, it will become 6 plus 4 10 and 8 plus 1 is 9. So this is divisible by 3, but not, this number is not divisible by 3. That means they are not coming in the same table. In 7 table also they do not come together. Okay, in 11 table it will not come together. So now they are not coming in the other table together. So up to this much only we will do. Okay, now what you have to do is that we have to find the product. Okay, so product of common prime factors is equals to, what you have to do, there are 4 3's are there, that means you will multiply 3 into 3 into 3 into 3. 3 3's are 9. Okay, you can do one by one. 3 3's are 9. Okay, again you can write like this if you have any confusion. Then again 9 3's are 27 into 3. Then 27 into 3 how much? You can multiply here, or you can multiply here 27 into 3 this way. 3 7 is 21, 2 carry 3 is 6, plus 2 is how much? Is 8. So what is the answer? Is 81. So what is the SCF? SCF of 5184 and 6561. So what is the SCF? Is 81. This is the SCF. So in this way you have to do by the method of common division. Okay, by using common division method. Okay, so now you see here that 3 numbers are given. So in the same way only you will do. Okay, here you have to see that all the 3 numbers should be divisible by that one particular number. Okay, same way only you have to do. Now let us see what is question number 4. Question number 4, find the SCF of the following by prime factorization method. So I have already taught you here also one. So again let us do by prime factorization method. Okay, so now let us see how to do. We are going to do this SCF by prime factorization method. So let us see. This is 17,472. Okay, and this one is 23,296. So let us start. The last digit is even 2, that means it is divisible by 2. So let us start with 2. So 2, how much is 17? It doesn't come. So less than what comes is 16. So 2, how much is 16? 2 8 is 16. So 17 was there. 1 given to it, it becomes 14. So 2 7 are 14. Now 7 is there. 7 doesn't come. Less 6 comes. So 2 3 are 6. 1 carry. So 2 6 are 12. Okay, so again by 2, because even is there. 2 4 are 8. 7 is there, 2 3 are 6, 1 carry, it becomes 13. Okay, so 2 6 are 12, 1 given to it, 2 8 are 16. Again 2 2 are 4, 2 1 are 2, 1 given to it becomes 16. So 2 8 are 16, 2 4 are 8. Again by 2 only, 2 1 are 2. Now see here carefully that we have written 2 1 are 2. Now what is there? 1. Next number is what? 1. So 1 doesn't come in, it doesn't come in 2 table, no, it is less than 2. So what you have to write is 0. Okay, you have to write 0. Then this 1 will be given to this 8, it becomes 18. So 2, how much 18? 2 9 are 18. Again 2 2 are 4. Again by 2, 2 5 are 10, 2 4 are 8, 1 carry, 2 6 are 12. Again by 2, 2 2 are 4, 1 given to it, 5 was there. So 2 7 are 14, 2 3 are 6. Now let us check whether it will come in the 3 table or not. Okay, so let us add for 3. So 2 plus 7 is 9. 9 plus 3 is what? 12. That means it will come in 3 table, as 12 is divisible by 3. So 3 9 are 27. 3 1 are 3. Now 91 is there. Okay, so whether this is divisible by 2, 3 or not. So by 2 it will be not. By 3 it will be not, because 9 plus 1 is how much? Is 10. Okay, so it will not be divisible. So whether it is divisible by 7 or not. So to know whether it is divisible by 7 or not, what you have to do is that you have to use the divisibility rule. So last digit is what? Is 1. So whatever the last digit will be there, what you have to do? You have to double it. You have to multiply by 2. So 1 2 ja 2. Now what is remaining is 9. So you have to subtract, okay, this 2 from 9. So 9 minus 2 is how much? Is 7. So is this 7 divisible by 7? Yes, it is divisible. That means this 91 is also divisible by 7. Okay, so I hope you have understood the divisible by 7. The last digit you have to double it. Okay, and whatever you get by doubling it, you have to minus from the number which is in front. Okay, so now let us do 7, 1 just 7. 2 given to it becomes 21. So 7 3 ja 21. Now 13 is a prime number. It comes in its own table. So 13 1 ja 13. Okay, done. Now let us check for this even number is there at last. That means by 2. 2 1 ja 2. 2 1 ja 2. 3 is there. 1 given to it, it becomes 12. So 2 6 ja 12. 9. That means 2 4 is 8. 1 given to it, it becomes 2 8 ja 16. Okay, now again by 2. 2 5 is 10. 1 carry to it. 2 8 is 16. 2 2 is 4. 2 4 is 8. Now again by 2. Last digit is even. When you will get the last digit even, you have to do by 2 only. So 2 2 is 4. 1 given to it becomes 18. So 2 9 is 18. 2 1 is 2. 2 2 is 4. Again 2 1 is 2. 2 4 is 8. 9 was there. 1 given to it becomes 11. So 2 5 is 10. 1 given to it, it becomes 12. So 2 6 is 12. 2 7 is 14. 5 is there. 2 2 is 4. 1 given to it becomes 16. So 2 8 is 16. Again by 2. 2 3 is 6. 7 was there. 1 given to it becomes 12. So 2 6 is 12. 2 4 is 8. Again by 2. 2 1 is 2. 3 is there. 1 given to it becomes 16. 2 8 is 16. 2 2 is 4. Again by 2. 2 9 is 18. 2 1 is 2. Now 91 we got. We see here we have already done. So it becomes easy for us. 7 1 is 7. 2 is there. So 7 3 is 21. 13 1 is 13. Now what you have to do is that we have to write the prime factors. Okay, so prime factors of this 17,472 is how much? How many 2 is there? 1 2 3 4 5 6. Okay, so we'll write here 2 into 2 into 2 into 2 into 2 into 2. Okay, at last what is there? 3 into 7 into 13. Okay, now we'll write for this. How many 2 is there? 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. 2 3 4 5 6 7 8 into 7 into 13. Now we have to find the common. Okay, we got the common. See here, common. Now see, this is left and 3 is not common here, so we'll leave. 7 is common, 13 is common. Now what you have to do is that you have to write the common one. Out of this 2 you have to write 1. So how many common are there? 1 2 3 4 5 6 2's are common. 2 into 2 into 2 into 2 into 2 into 2 into 7 into 13. So it's very easy. Now you have to find the product of this prime factors. So let us start. 2 2 ja 4. Okay, 4 2 ja 8. 8 2 ja 16. 16 2 ja 32. 32 2 ja how much is 64. You can multiply and do it one by one, or you can do it directly. Okay, 2 2 ja 4. 4 2 ja 8. 8 2 ja 16. 16 2 ja 32. 32 2 ja 64 into 7 into 13. So 7 into 13 how much? 7 13 ja, or you can say 13 7 ja is how much? Is 91. So now we will multiply this. 1 4 ja 4. 1 6 ja 6. Okay, 9 4 ja 36. 3 carry. 9 6 ja 54. 54 plus 3 is how much? Is 57. Now we'll add this 4. 6 plus 6 is 12. 1 carry. 7 plus 1 is 8 and 5. So how much we got is 5,824. That means SCF of 17,472 and 23,296 is how much? Is 5,824. So this is the answer. Okay, this is the answer. Okay, this is the SCF. Okay, so I have chose the biggest number, that is I have done question number F. Okay, so today I have done 4 questions as big numbers were there. Okay, so for today up to this much. In my next class I will do these all questions. Okay, and I will complete this exercise and we will move to the next exercise. Okay, so whatever I have done you will do in your copy as a classwork, and I will give you some questions for your homework. Okay, so for today up to this much. I hope you have understood. Thank you.